Today we're going to talk about slope section 8.6. The objective is to find the slope of a line. So what is the slope of a line? It's a line's rate of change, right? So slope is a line's rate of change. So when I was in high school, I went to a running camp every summer. And you would start in Indiana, you would get in vans, and you would ride out west. You would go through Illinois and Iowa, Nebraska, and you'd end up in Colorado and Wyoming. It was a 2-week camp. It was great. And in Colorado, there was a run called the Devil's Gulch Run. And if you were to look at the elevation change of this run, the first 3 miles were a steady incline, but then the last mile was pretty much this. Okay, so the slope of the first 3 miles was relatively low, right? So we'll say it's a small slope, or you might say a low slope, something like that. But then in the last mile, it got very, very steep. And so it was a big slope. So the rate of change was gradual for the first 3, but then the rate of change in that last mile was drastic. It was a big slope. And that's what we're measuring today. We're measuring the rate of change. And the same thing happens with lines. So the smaller a slope, the smaller the number it's going to be. And I shouldn't say small, I should say closer to 0. And the bigger the slope, the further away from 0 it's going to be. Now, slope can be positive or negative. If it's positive, right, positive slope, it's going to be sloping up and to the right, like this, okay? Up and to the right. If it's a negative slope, how do you think it's going to be sloping? It's going to be sloping uh, down and to the right, down and to the right. So always think about moving left to right. If we're moving uphill, as you look at it from left to right, like my run in Colorado, or that would be a positive slope, right, going up and to the right. Or if you're going down and to the right, that's what we call a negative slope. And so when we say positive, like it's going to be a positive value. When we say negative, it's going to be a negative value. So we'll get to this later today. By the way, on the Devil's Gulch run, it was 4 miles uphill, 4 miles downhill. It was an 8-mile race. Now the last 4 was downhill, so it wasn't that painful. But the last mile going up was quite painful. So we can find the slope of an equation in 2 ways: one graphically, 2 algebraically, and we're going to take a look at both of those today. So finding slope by graphing. Slope is also sometimes referred to as rise over run, sometimes referred to as rise over run. So what is rise? We're talking about a vertical change. That is what would be considered the rise portion over a horizontal change. So what is vertical? It means to go up or down. What is horizontal? It means to go left or right. So you're going to hear me reference rise over run a lot. When you hear rise, think vertical change, up and down. When you hear run, think horizontal change, left and right. So find the slope graphically. First, let's find 2 points. So step 1, find 2 points. Doesn't matter what 2, but find any 2 points on the line. So we've got one right here, and we've got one right here. So this is the point 0, 1 there, and this is the point, let's see, that is 5, 5, 5, 5. So when we talk about rise over run, first we're going to find the vertical change, and we do this by counting. So what is our vertical change? To go from this point here, 0, 1, to this point here, 5, 5, we have to go up. We go up 1, 2, 3, 4. So we went up 4, right? Up 4. You don't have to do this. You can just count. That's good enough. So the vertical change in this case is 4, positive 4. And then next, we find the horizontal change. By the way, our vertical change, we call that rise. And the horizontal change, we call that run. So we go to the right now. And how far to the right did we go? We can count 1, 2, 3, 4, 5. We went to the right 5. Okay. And then step 4, we put it in the form of rise over run. That is a fraction, right? So the rise over run in this case is going to be, let me erase that equal sign. The rise over run here is going to be, well, we went up 4, so that's a rise of 4. We went to the right 5, so that's a run of 5. So 4/5 is the slope here. Now, let's say you started at the other point, 5, 5, and you went to 0, 1. Well, now you're going down 1, 2, 3, 4. If you go down, that is negative, excuse me, that is negative 4. Negative 4. So the vertical change, if you're going down, that's a negative direction, right? Think about your y-axis. If you go down on the y-axis, you get to negative numbers. So when we go down, we consider that a negative change. And then we go to the left. Well, if you go to the right, that's a positive direction. To the left, that's the negative direction, right? If you go all the way to the left, you start hitting these negative numbers here on the x-axis. So how far left did we go? 1, 2, 3, 4, 5. So that's negative 5. What if you did this? A vertical change of negative 4 over a horizontal change of negative 5. Well, what is negative 4 over negative 5? It's positive 4 over positive 5. So no matter which point you start at, whether you started at 0, 1, or 5, 5, you will get the same slope either way. But you do have to pay attention to whether you're moving in a positive direction or a negative direction. Up is positive, down is negative. Right is positive, left is negative. You'll get the hang of it if you didn't get this. Graph a line that passes through negative 2, 3, and 3, negative 3. After you've graphed that line, find the slope. So all you have to do is plot these 2 points, connect the dots, and then find the slope. So pause the video now and try that on your own. All right, hopefully you have that done. Negative 2, 3, negative 1, 2, and then up 3. 1, 2, 3, right there is the point. Oops, excuse me. Negative 2, 3. Double check. 1, 2, 1, 2, 3. There you go. Negative 2, 3. And then 3, negative 3. 1, 2, 3. Negative 3. 1, 2, 3. Right there. All right. So 3, negative 3. And this was the point negative 2, 3. And now we need to graph that line, so we connect the dots. There we go. Doesn't have to be perfect, but remember your lines are never supposed to curve. If it does, you made a mistake somewhere along the way. So there's our 2 points, negative 2, 3, and 3, negative 3. Now think about how we find the slope. It's rise over run. Rise over run. That's your vertical change over your horizontal change. So rise, it's going to be our vertical change. I'm going to start from negative 2, 3, and I'm going to go down. You don't have to show these dash marks. You are welcome to just count. But while I'm teaching you, I'm going to show the dash marks. We go down 1, 2, 3, 4, 5, and 6. So that's negative 6 because we go down, right? One more time, let's double check. 1, 2, 3, 4, 5, 6. And then we have to go to the right to get to 3, negative 3. How far to the right do we go? 1, 2, 3, 4, 5. One more time. 1, 2, 3, 4, 5. So if we go to the right, is the right the positive direction or the negative direction? It's the positive direction. So right 1, 2, 3, 4, 5. So our rise is negative 6. That was our vertical change over the run. That's the horizontal change, positive 5. So the slope here is negative 6, 5. Now you remember earlier on when I talked about positive sloping lines versus negative sloping lines? Positive sloping lines go up and to the right. Negative sloping lines go down and to the right. So let's look at the first one we graphed right here. This has a slope of 4/5. That's a positive slope. It goes up and to the right, up and to the right. This line goes down and to the right. That's negative sloping, and you'll see we do have that negative sign out front. So that is not a coincidence that this one is negative and this one is positive. So if you would have gotten a negative slope for this line, you should know I made a mistake. Positive sloping lines go up and to the right. And if you got a positive sloping line for this line, you should think I made a mistake because positive sloping lines go up and to the right. This one goes down and to the right, so it needs to be negative. Try this one on your own. Graph a line that passes through 2, 5 and 1, 2, then find the slope. Pause the video now and try this one out. All right, first the 0.25, to the right 2, up 5, right there, there's the 0.25. Then the 0.12, to the right 1, up 2, there's the 0.12. Now let's connect those dots to create our line. Something like this. Hopefully yours is a little bit better than mine. If it curves a little bit because you're just a little sloppy like me, not the end of the world. If it curves because your lines or your points are plotted in the wrong place, that is a problem. So first, before we find this slope, is this going to be positive or negative? This goes up and to the right. Up and to the right, this is going to be positive sloping. Say positive slope. So we're going to go up how far? 1, 2, 3. We went up 3. Is up the positive direction or the negative direction? It's the positive direction. Remember, down's negative, up is positive. And then we have to go to the right 1. To the right 1. So rise, the vertical change, is 3. Run, the horizontal change, is 1. 3 over 1, that is our slope. Is that positive or negative? It's positive. Should it be positive? Yes, it should. What does 3 over 1 simplify to? So as a fraction, 3 over 1 simplifies to 3. So that is your slope, 3. By the way, there is a letter we use for slope. It is m. So m, your slope, is equal to 3 in this case. Questions on that? By the way, if you went down 3, 1, 2, 3, that's negative 3 because you're going down, and then left 1, that's negative 1. Negative 3 over negative 1 simplifies to 3. So either way, you should get 3. If you did not, you probably made a mistake somewhere along the way. All right, now just to reemphasize some things we've already gone over, slope, or m, of a line describes its steepness. Remember my run in Colorado, it was not very steep at first. That would still be a positive slope, but it would be closer to 0. And then as the run went on, it got very steep, so that would be further away from 0. So maybe we'd have a slope of 1 at first, and then as the run went on and it got super steep, maybe a slope of 3 or 4. You get further from 0. The vertical change is called the change in y, or rise. The horizontal change is called the change in x, or run. Now we have a formula for this, change in y over change in x. And we're going to put some numbers to this in just a moment. So finding the slope algebraically. Find the slope of the line that contains the points a, negative 2, 5, and b, 4, negative 5. Then graph the line. Okay, take a look at point A. This is an x or a y coordinate here, negative 2. That is an x coordinate. So we're going to call that x1. Now, doesn't matter which x you call x1. I could have called negative 2x1. I could have called b x1. But whichever one you called x1, it's going to be paired with y1. And then the other x coordinate, which in this case is 4, is going to be called x2. And it's going to be paired with y2. And then we can use our formula, the change in y, right? So m is equal to the change in y over the change in x. So to find the change in y, we're going to say y2 minus y1 over change in x, x2 minus x1. So with this particular example here, y2 is what? y2 is negative 5 minus, I'm looking right here, y1. What's y1? 5 over x2. Where's x2? It is 4 minus x1. What's x1? It's negative 2. Now be careful here. We're subtracting a negative. What happens when you subtract a negative? You have to add, right? So negative 5 minus 5 is negative 10. Negative 4 minus negative 2, this becomes, I'm sorry, back up. I said negative 4. It should be 4 minus negative 2, When you subtract the negative, you have to add, so that's 4 plus 2, which is 6. Can we simplify this fraction? We can. We can divide both these by 2. It gives us negative 5 over 3. So m, our slope, is equal to negative 5 over 3. This might be something you have to watch a couple times in this video because you're going to apply it a few times. So remember, rise over run, change in y over change in x, or algebraically, y2 minus y1 over x2 minus x1. Doesn't matter which one you call x1, but it's always paired with y1. I should say it doesn't matter which x coordinate you call x1, but it's always paired with y1. And then the other x coordinate becomes x2, and it's paired with y2. All right, another one. I want you to graph this one first. Find the slope of a line that contains 2, 6, that's point A, and point B, negative 3, negative 8. So graph it first, find the slope graphically, and then find the slope algebraically. Okay, so I have plotted these 2 points, and I hope you have too. Negative 1, negative 8 is down here. Negative 3, 4, you'll see that there. All right, so first ask yourself, is this going to be a positive or a negative slope? Is it positive or negative? It's sloping down and to the left, which makes it a negative slope. First off, the vertical change. Let's start from negative 3, 4. You don't have to, but I'm going to. To go from negative 3, 4 down to negative 1, negative 8, how far down do we have to go? Well, look at the y's. We're going from 4, we're going from 4 to negative 8. 4 to negative 8. If we're going from 4 to negative 8, we got to go down 4 to get to the x-axis and down another 8 to get to negative 8. So if we go down 4 and 8, we went down 12. So negative 12 is our rise over our run. So how far to the right do I have to go? Look at the x's to figure out your horizontal change. To go from negative 3 to negative 1. If you're going from negative 3 to negative 1, we go to the right. So we know it's going to be positive. How far to the right do we have to go? From negative 3 to negative 1, that's to the right 2. And now we can simplify this fraction and we get negative 6 over 1, which is just negative 6. So that is our slope. Now let's find it algebraically. Remember, it doesn't matter which x coordinate you call x1, but it's always paired with y1. And then the other x coordinate becomes x2, and it's going to be paired with y2. So remember, the slope is equal to y2 minus y1 over x2 minus x1. I would advise you to write this down every time you use it until you have it memorized. So our slope is equal to y2, which is negative 8, minus y1, 4, over x2. Find x2. That's negative 1, minus x1. That's negative 3. So be careful when you're subtracting a negative. That means you have to add, right? Negative 8 minus 4. That's negative 12 over negative 1 plus 3. When you subtract a negative, you have to add. Negative 1 plus 3 is going to be 2, which simplifies to be negative 6. So either way, you get the same slope, negative 6. If you get different slopes, you know you made a mistake either algebraically or graphically. Just do this next one here algebraically. Find the slope of the line that contains 5, negative 2, and 0, negative 3. Pause the video now, find that slope. Okay, remember, it doesn't matter which x coordinate you call x1, but the other one becomes x2. So I called 5x1, and I called 0x2. If you did it the other way around, you should get the same slope unless you made a mistake. So y2 minus y1. y2, I called that negative 3, minus y1. y1, negative 2. When you subtract a negative, you have to add. So it's negative 3 minus negative 2. Negative 3 plus 2 is negative 1. y2 minus y1. I'm sorry, excuse me. x2 minus x1. x2, right? x2 minus x1. x2 is 0 minus x1, 5. So this is why you should always check this, because I flipped it around, didn't I? X2 minus X1. Good lesson to be learned here. Always check yourself. X2 is, and you see how I labeled it X2 and X1? So this way you can check again and make sure you got it right. So X2 is 0 minus X1 is 5. There you go. So what's 0 minus 5? It's -5. What's a negative over a negative? It's a positive, so this equals 1/5. So good lesson learned there. This is why we put these steps in. We write in x1, y1, these identifying marks. We write in x2 and y2. We write out our slope formula right here, and we check every step of the way. And we go back and we double check, because sometimes you do flip them around. It does happen. Just be careful, check and double check. It's not that you don't know how to do it. It's just that you have to be careful and be sure. Let's go ahead and graph this really quick to make sure we do have a positive sloping line. That's the power of graphing these, because if you graph them and you mixed up your signs, which that's what would have happened had I not flipped it around, the signs would have been mixed up, and I would have had a negative sloping line when I should have had a positive sloping line. So 5, -2. Nothing wrong with making a mistake, but it's important that you learn from it, right? There's 5, -2, and then 0, -3 is right there. So 0, -3 up to 5, -2, that is a positive sloping line. It's gradually going up and to the right. It's pretty close to horizontal, but it is going up. So from -3 up to -2. So yes, that is a positive sloping line, not a negative sloping line. All right, just a quick word on parallel lines. They never intersect. What's the relation between the slopes of parallel lines? They are the same. They are the same. So for example, if we have two parallel lines, so here we have two parallel lines. One line crosses through 2, 2. One line crosses through, 2, 2 and 5, 5. The other line crosses through 0, 3 and 2, 5. So let's find our slopes. You can do it using rise over run or algebraically. So pause the video now. Find the slope of these two lines. Okay, so first off, 2, 2 and 5, 5. We have to go up 3, so that's a rise of 3, and we're going to go to the right 3. So 3 over 3, that gives us a slope of 1. That was 2, 2 to 5, 5. We had to go up 3 to get to 5, 5, and right 3 to get to 5, 5. Now let's do the same thing for 0, 3, and 2, 5. To go from 0, 3 to 2, 5, we have to go up 2. We have to go right 2. So 2 over 2, that is also a slope of 1. So these two lines, their slopes are the same. And one last quick note here, a linear equation can be written in slope-intercept form, which is this form: y equals mx plus b, where m is the slope and b is the y-intercept. Y-intercept is where the graph crosses the y-axis. There's one last thing I want to share with you. We talked about parallel lines, horizontal lines. Horizontal lines, their slopes are 0, right? So if you're not going up or down at all, there is no vertical change. Slope has to do with vertical change over horizontal change. So there is no vertical change. So it's going to be 0 divided by something, which is always going to be 0. Now with vertical lines, it's the opposite. We're going to be dividing by 0, right? So now there's no horizontal change. And when you divide anything by 0, it's going to be undefined. So there you go. When you divide by 0, that is undefined. So if we have a vertical line, its slope is undefined. Horizontal line, its slope is 0. Vertical change is 0, divided by anything is 0. Horizontal change is 0. So anything divided by 0 is undefined. All right, good luck on your assignment today.